Hello, I want to go over a brief lesson here about basic addition rules for probabilities. Okay, the premise on addition rules for probability is whether or not two events are mutually exclusive. Okay, mutually exclusive, or sometimes I'll just say ME for short. Okay, and the idea is that two events that cannot occur at the same time. Cannot occur at the same time. Okay, for example, say we roll a die, okay, single die, and we look at the idea of getting an odd number and getting an even number, okay? So I'll say, can you be odd and even at the same time? And you're gonna say to me, no, you cannot. So I would say that this is yes, mutually exclusive, okay? They cannot occur at the same time. Or another one is, let's say a single die is rolled. Can you get an odd number and a 3? So can you be odd and 3 at the same time? So you will say, yes, I can be odd and 3. So then I would say, no, these events are not mutually exclusive. Okay? All right, so let's get into these addition rules for probability. If two events are mutually exclusive, so they cannot occur at the same time, then the probability of A or B occurring is probability of A plus the probability of B. Okay, so if you see an or, we're saying to add up the probabilities. All right, example. A drawer contains 3 pairs of red socks, 2 pairs of black socks, and 4 pairs of brown socks. What's the probability of black or brown? Okay, well, can you be black and brown at the same time? You're gonna say, well, no, okay. So the total pairs of socks up here, if you add them up, 3, 4, 5, and another 4 makes 9. So we wanna do probability of black sock plus probability of brown sock. So black socks, there's 2 pairs out of the 9, plus brown socks, there's 4 pairs out of 9. Whoopsie. Yep, out of 6. Now it won't let me erase it. Oh, there it did. All right, let's try that again. Sorry, folks. 4 pairs out of 9. So we end up with 6 out of 9, or 2/3 for the probability. Okay, let's go again. When a single die is rolled, find the probability of being an odd number or a 4. Okay, so odd like 1, 3, 5. So that makes 3 out of 6 ways to be odd. Or means add. Chance of a 4, 1 out of 6. So the probability is 4 out of 6, or 2/3. Guess I have a thing for 2/3 today. All right, next one. A day of the week is selected at random. Find the probability that it is a weekend day. All right, so weekend meaning Saturday or Sunday. So there's 7 days in a week. There's 1 Saturday or 1 Sunday. We can't be both. So there's a 2 out of 7 chance of being a weekend day. All right, continuing on. We've got rule 2. If two events are not mutually exclusive, then the probability of A or B is probability of A plus probability of B minus the probability of A and B. So sometimes I'll refer to this part as the overlap that we have to subtract, okay? All right, so we got an example. A single card is drawn from a standard deck of cards, okay? Find the probability that it is a king or a club. All right, well, if you play cards, you'll know there's 52 cards in the deck, okay, and that a king of clubs exists, so that I can be both king and a club, okay? So we're gonna do probability of a king, which there are 4 kings out of the 52 cards, so that's king, plus clubs, there's 13 out of 52 clubs in a deck, minus the king and the club, there's one of those. Okay, so we end up with 16 out of 52, and that reduces to 4/13. Okay, if you don't know cards, I did put a reference sheet in your Schoology. You can pull that up and print it off as needed, okay? All right, second example here, I wanted to do because I want to put this information here together into a chart. So it says in a hospital, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are female. Find the probability that if a staff person is selected, the person is a nurse or male. All right, so here's my suggestion. Let's make a little chart to summarize the information. So we have nurses, physicians, we have female, male, total. I guess I should, well, this will work here. All right, so what do we know? We know there are 8 nurses and 5 physicians. So I'm going to start here with an 8 and a 5. Okay, so we've got a total of 13 people, okay? How many are, let me see, 7 nurses and 3 physicians are females, okay? So 7 and 3, okay? So then that means that we've got 1 male and we have 2 male physicians, okay? So now what in the world was the question? We want the probability of nurse or male. Okay, so the probability of being a nurse is going to be 8 out of 13 plus probability of male, okay, so we got to get this total here for male, 3 out of 13. And then you want to subtract if you can be a male nurse. Okay, well, male and nurse is that 1 right there. So that would be a minus 1 out of 13. So our answer for that one, 10 out of 13. Okay, so that's a way, and I could put the 10 there. That's a way you can use a chart to kind of summarize data to help you figure out what you got for your setup. All right, and then lastly, I'm going to take this one and look at mutually exclusive for 3 events. You can add this one in, and if it's not mutually exclusive, check out that one. Okay, for our work, we're not going to do anything with those, so that's the way it goes. All right, thank you for watching, and good luck with the addition rules.